right, good evening, good afternoon, whatever time of day it is that you're listening here. Mrs. Story and I are both here.
Hello, everybody.
We are tag teaming the next lesson, and the next lesson is actually going to also consist of a review of what we got into this past week, which was over slides 8 and 9. Let me back this back up a little bit. Last week you reviewed slides 1 through 7. That's stuff we talked about before school ended, physical school ended. And then we asked you to look at slides 8 and 9. I promise you there are embedded videos here that you should have seen and been able to click on. And I apologize. I tried everything I knew how, but they are embedded here in the actual PowerPoint. But once I uploaded to Schoology, it was like you couldn't click on it. So these are great videos to see and get some information about these different types of tests. We want to just review that a little bit with you, and then we're going to go forward with new content and look at 4 additional slides.
And real quick, Mrs. Taktak and I discovered that if you download the video, you should be able to access those links, but then we were still concerned that maybe that wouldn't work. So we loaded the video links separately within last week's folder. So again, if you have not done this activity yet, you want to make sure you go back and review the PowerPoint and watch the videos, simply because they give good information and examples that are not in the words that you'll be looking at on the PowerPoint.
Yeah.
So just make sure you get that done.
Yeah. So just reviewing, you guys did the video lab. This is something we were going to do very similar lab we were going to be doing in the classroom. And unfortunately, we had to go to a video, but you did a wonderful job. Those that have submitted their video lab papers, very, very nice job with that.
Yeah, especially your data tables were filled out beautifully for most people.
Yeah, perfect. So I think everybody got the idea of kind of how the color tests work. And we wanted to talk about the word presumptive because it was mentioned, and it's important to note that these rapid color change tests are presumptive tests, which means they're done kind of as a first quick, cheap way to see if something suspicious might be a drug or poison that's worth collecting.
Right. And simply because sometimes they can give a false positive or a false negative, they need to be backed up. If there is suspicion that a particular toxin is there, they need to be backed up with additional testing, which are what we're going to talk about here in a few minutes. So they are what is called presumptive, meaning that it's not a definitive answer by itself. And that's why color tests are not allowed as evidence in court. They're considered inadmissible or not admissible.
Yeah, but important because it's just a quick way to say, hey, is this worth collecting for further testing? If we get into blood, hopefully we'll get into blood here before the year ends out. We'll talk about presumptive testing for blood. So you'll hear that term again probably in the coming weeks. Okay, next is the immunoassay testing, which is testing that's done for more biological substances because it is an antigen antibody reaction, which means it's protein based. You have antigens, which are on the surface of your cells, and there's antibodies, which are proteins that are out in the blood plasma. If there are antigen antibodies that come together and they match up, sometimes if you're talking about blood, it'll actually clot, which is a bad thing. But in the instance of drugs, poisons, viruses, you can also develop tests, as you're hearing about coronavirus testing right now. You can develop tests to see if certain antibodies are present to respond to certain conditions.
And that antibody is made by your cells, to fight the foreign antigens, those foreign proteins of what other substance maybe should not be in your body. So like in the case of a virus. And so again, you make the antibody, the antigen is what triggers that antibody being made. So if you have antibodies in your system against a particular antigen, that means you have been exposed to that particular substance.
Yeah. Another example is anthrax. Anthrax is like a bio weapon, so to speak. If you could poison somebody with anthrax and cause them to die. So that immunoassay testing is going to be basically more of a biological type of a test that's designed to interact with these antigens and antibodies. Okay. Next type of testing is called gas chromatography. And we wanted to kind of just go over what that word means. Chromatography, literally chroma, the prefix chroma means color. And then graph, to graph something is kind of separating it. So it's kind of like separating colors. And why do they call it that? Gas chromatography. Where does that come from? Wanted to show you a demonstration here. So I'm actually going to switch to my document camera. This is doing all kinds of interesting things now. And Mrs. Story and I are doing a little kitchen science here for you, and she's going to do a demonstration.
All right, so we've got a little piece of filter paper that we've cut a tip so the tip can go down into a solvent. And you can use different kinds of solvent. You can combine substances. I did a biology lab when I was in college that required ether, which is something they use to put people to sleep. So we had to be real careful when we were using the ether. It's flammable, but we're just going to be using water today. And so we cut the tip of the filter paper into a strip. On that strip, I've now put a green dot simply because green is not just green. And that's the purpose of chromatography, is to show what substances combined together create a particular thing that you're looking at. In this case, our thing is this green dot. And then we'll take a glass of water. If we were back in the classroom, we'd have a beaker. And when you put the tip so that the solvent begins to be absorbed by the filter paper. And once this gets going, I'll turn it so we can see it better. Maybe if I tip it. And we'll just kind of, there we go, that's better. We'll just kind of watch. And this takes a few minutes. So Mrs. Taktak and I have a couple of strips to show you that we've already done. But you can see that the green now is being carried up by the solvent up through the filter paper. And if we continue to let that go, then eventually, we did a couple to show you. Eventually, you'll see, particularly on this one that we let go the longest, that green actually has multiple shades of green and yellow in that to make that initial color of green that you were seeing.
So this is the first example of the word like when I did chromatography in high school, college, this is what we did. We separated out based on color. Now, they don't separate drugs and poisons out based on color, but the word chromatography comes from what we just saw there. Let me see if I can get this back over here. And they have a machine now that's called a gas chromatograph, which does gas chromatography. And it basically separates compounds out according to size, shape, and other chemical properties. It doesn't give the exact makeup, but it does give class of compounds. So that can be really helpful if you're trying to figure out what a substance might be. So still a little bit pricey, but it's one of the more common machines that are available for testing to help determine what compound, what drug might have been used to poison somebody. Next is ultraviolet spectroscopy, and I did not find a good video. I looked for a good video for that, but there just wasn't one to show. What I can tell you about that, and we mentioned this when we talked about fiber testing in Forensics 1, but this is a machine that will record the wavelengths of light that are reflected off of something. So you can use this for fibers. You can put a fiber in and then it'll pass a light through, but it'll reflect light back and it'll measure what's reflected off. And then it basically spits that onto a computer screen and gives the wavelength. So it can kind of also help give the class of the compound. Usually it's not going to give you an exact compound, but it kind of gives you an idea of the class. And then you can kind of use it to compare that to other known samples and get an idea of what you're dealing with. And then lastly is mass spectrometry. And that is going to be the most expensive, most serious of the tests. That will give you the exact chemical property and chemical makeup. Very, very expensive. It deals with the high energy electrons that are passing through a substance and breaking it all apart chemically and then reanalyzing it. And there's a really good video, if you didn't watch it, if you want to know more about how that works, there's a good video that kind of explains that. But that's the most expensive and but it's the most accurate if you want to find out exactly what's in that drug or poison.
And Mrs. Talk and I were talking about the fact that probably a lot of just city or county crime labs would not have the ability, the funding to have this particular type of equipment. Maybe this would be something they would send off to the FBI for analysis, because most likely the FBI crime labs would have this capability.
Yeah.
So, and again, before we go on to the next slide, just all of these are additional tests that could be done after the color test that you all experimented with was completed, if there were any questions or needed further testing.
Yeah. All right. Now we're in a new material. So again, I would just invite you to take your notes out if you have them, and you can pause your video. You can fill your notes in, and that way you have a complete set of filled out notes, because we will eventually have a test on this material. So it might be good to have all your notes in one place. We're going to look at just a couple new slides today. The first thing we want to talk about is points of administration. How does a drug get into someone's body? Where are the points that that drug is administered into someone's body? And so these are some points here of administration that are the most common. The first one is called ingested toxins, and that ingested means you've eaten it, and it's going to, of course, show up more in the stomach, intestines, and liver. And I think back to that Mary Lafarge who poisoned her husband and fed him all of this arsenic food. He was poisoned with arsenic, and it was ingested. So they actually showed in that Catching Killers, they showed how they saved his stomach, or they dug his stomach back up. I forget which, but they brought the stomach into the courtroom and tested his stomach, and that's where they found high levels of arsenic eventually in his stomach tissue and the food that he ate. Next is inhaled toxins, and inhaled toxins can show up in the lungs.
Right. And Mrs. Talk and I had discussed a couple of different ways maybe that are some examples of inhaled toxins. So huffing, which was something that was kind of popular a few years back, where people were huffing different aerosol cans trying to get a high. So obviously that would be the point of entry, or the way of administration would be in through the lungs. Also too, there's a substance called anthrax, which we don't know if you're real familiar with that, but it's something that is concerning as far as being used maybe for biological warfare, that is basically inhaled, and that's how the toxin gets into the body.
Yeah, it destroys the lungs. Injected toxins, injected into tissue, and that can linger around the tissue where someone's been injected. Side note, muscle tissue slows down the transfer to the bloodstream. So if you inject directly into the muscle, it's not going to flow around the bloodstream as quickly as it would as if you maybe were subcutaneous and you hit capillaries, just say.
And so maybe a quick example of an injected toxin might be heroin, or Mrs. Talk, is LSD injected, or is that through contact with the skin?
Yeah, I was thinking that was even like on things people licked and.
Right, but definitely heroin
for sure
would be a good example of an injected toxin.
Yeah, or injected drug. Yeah, injected toxins could even be like that succinylcholine,
right?
That they used to
for paralysis,
yeah.
right? Prior to basically putting someone through an anesthetic.
Yeah, and then finally, IV, which I think of that Dr. Death in Catching Killers, how he poisoned his victims through IV drips, and that will bypass the stomach and liver, goes directly into the bloodstream, so it's very quickly distributed. Very little does remain in the IV site.
So that one's kind of hard to trace, and that would be kind of a subcategory of an injected toxin. That the difference between the two is the IV is injected in through or into an IV.
Yeah, right into a vein.
Not just into the skin.
Right, yeah. And again, that Dr. Death pretty much poisoned his a lot like that with succinylcholine.
Right.
Oftentimes, yeah. All right, so those are different points of administration. These are some side notes. The next two slides are just kind of some side notes on testing. Once the testing is done, the toxicologist evaluates what toxins are present based on those tests that we just talked about. They identify the routes of administration that we just talked about.
How the poison got in.
Yeah. And then determines whether the concentration is sufficient to play a role in the subject's death or behavior. That's going to be all part of their report. Now, the route of entry is very important. It's extremely important in cases of injection where the person had no means to inject or no physical capabilities to inject themselves. And in that case, then homicide is a stronger consideration.
So in other words, it's not something the person chose to do. It was something that was done to them.
Yeah, like if somebody was on a hospital bed and they were injected and they didn't have the means to that or something, or in a coma, or yeah. Okay, be aware. Caution, be aware. Finding a large quantity of toxin in the stomach does not mean it is the cause of death. Someone could have ingested toxins into their stomach, but that doesn't necessarily mean it was the cause of death. So they don't rule something a homicide just based on toxins being found in the stomach. It also would have to be confirmed that the toxin would have maybe gotten into some other organs to cause organ failure.
Right. And it takes a little time for the contents of the stomach to flow through to the small intestine, and that's where the distribution into the blood happens.
Right.
So just finding things in the stomach itself does not mean that that caused their death.
Right. Blood concentration still the most important. Okay. And this is going to be our last slide, and we're going to look at concentration categories by the toxicologist. So if they find toxins in your system, how do they categorize it? And there's these 4 levels here. Normal, which is expected in the general population under normal circumstances. This surprised me when I first looked at this because it basically is saying that any one of us could walk in and they could draw our blood and probably find some level of certain toxins in our blood system. And there would be a normal amount. And how would we get toxins in our blood? Well, how could we get that? What do you think?
Well, I'm thinking maybe just through drinking and eating. So there probably are a certain level of toxins in the water supply that are acceptable or considered normal.
Yep.
What else can you think of?
I don't know. Maybe even through your skin, if you have household chemicals that you're cleaning with, your cleaning products could have certain chemicals in them.
Right, or just inhaling natural pollutants in the environment that come from car exhaust or whatnot. And we're even exposed all the time to just background radiation that just exists in the soil.
Yeah.
So yeah, toxins are all around us, but our body is designed to kind of accept those and
a certain amount
and still consider that to be normal and acceptable.
Yeah. But there's also a therapeutic level of certain toxins if you're taking medications that a doctor wants in your bloodstream for medical reasons. So if you're like on an antidepressant or blood pressure medication.
Right.
Yeah.
Or I'm trying to think, my husband has a thyroid that doesn't work very well, so he has to take medication to increase the amount of hormones that his thyroid puts out. So, I mean, there are kinds of drugs that are designed to help you. They're therapeutic. They're therapy for you.
Yeah. And now even just it's worth a mention with medical marijuana. I mean, certain states allow that. I think our state allows that now in Ohio. You have to have a prescription for that. But, if you were taking marijuana and found to have that in your system, it might be a therapeutic level. Toxic, obviously, is a level that could cause harm. So nausea, vomiting, diarrhea, change in your heart rhythm. Those are going to be side effects of having a toxic level of drugs or poisons in your system. And then finally is a lethal level. And a lethal level would be a level at which the toxin consistently causes death. Now there's a subcategory under that, which is LD50. Now LD50, we're going to do a separate lesson on this, but we are going to get into LD50. LD50 means the toxin at that level causes 50% of people to die. And it is a very important term in this talking about drugs and poisons. LD50 is an important term that we want you to know about. So we're going to do a separate lesson on that.
Absolutely. And what would make some people die and not other people die at that particular level of the dosage is kind of listed in the information below. So kind of depends on your body size or your sex or your age or even your genetic makeup and just kind of your overall health. So I know, for instance, my husband, if he takes, let's say, something for a headache, he has to take more of it than I do to get rid of the headache simply because he has a bigger body than I do. So it takes more to dose him. So that's sort of the things that we'll be talking about.
Yeah. Okay, well, thank you for listening and following along and completing your ed puzzle. And we'll get into the next lesson and look forward to seeing your submissions.
Absolutely. Have a good rest of your day, everyone.
Yeah, have a great day, evening, whatever time it is for you.